Alright, so we've had a look at roughly how they're made. Now we're going to look at how we use polymers. We're going to look at several in particular, including styrene, polystyrene, and polyvinyl chloride. And yeah, let's have a look. So you want me to describe how specific polymers are used in industry, and you want to be able to describe specific polymers chemically. So let's have a look at our three right here. So we've got chloroethene is the monomer. Now this is the very simple monomer here. The common name for it is vinyl chloride. The polymer is called polyvinyl chloride. See, they're all poly. And we use it for containers, wrapping, blister, packaging. It's actually probably one of the more common used plastics that you're thinking of, like bottles, vegetable oil bottles. They're all going to be polyvinyl chloride, but there's also some. It's got very wide properties, but we'll see those in a second. So it produces a wide variety of products, just said, and they are fire retardant generally. Now we've got propene nitrile, vinyl cyanide, or acrylonitrile. Now this here is what gives us the vinyl cyanide name. That's the drama there. You use it in textiles, dinnerware, food containers, toys, luggage, car parts, telephones. And it's sold under a bunch of different names, but if it's pan or polyacrylonitrile, that's what we're looking at. And over here, we have ethylbenzene. Ethylbenzene, see that's your benzene ring right there. Or styrene, or vinyl benzene, they're the common names for the monomer. And polystyrene is what the polymer is called. This is the one that you see everywhere as in the in one way, but you're going to see it in another way that you're not quite thinking of. So you see it in fruit boxes, packing foam, meat trays, blah blah. But you also see it in the weird ones: coat hangers, toys, cutlery, cassette cases or CD cases. That's an old one. An old table. Compact disc cases, compact discs. So here we've got these nice big fluffy puffy things that we use for packing, but here we have some very hard plastics, and that's the thing that a lot of people get confused with PVC. Polystyrene. So it is durable. It's a great insulator. It's not just a good insulator. It's a great insulator. It's low cost, very light, and the shape can be molded to protect, other things as casing. So it can be molded, and that's really good. All right. So why is PVC the most important polymer ever? Essentially, it's used to make social distortion records, and that's like the greatest thing in the world. Now, let's have a look at them as these three polymers in particular. So we're going to look at ethylene now, as well as our vinyl chloride and our styrene. Systematic name, ethene, chloroethene. That can also be called the IUPAC name, and ethylbenzene. The name is low density, so here it splits into two already. So bang, into two different ones. Low density polyethylene, high density polyethylene. Polyvinyl chloride, polystyrene. Your LD is low density and soft. Your HDPE is high density and hard. PVC is made rigid and flame resistant with additives. So we add this stuff to it to change the properties, and it is water resistant. That's really important. These guys aren't so water resistant. Styrene is transparent due to the fact that it makes no crystals or low numbers of crystals. And when you gas it, so as it's being made, you squirt gas into it, it makes a foam. The gas would be CO2, by the way, because it's not going to react with it. What are we using for? This one here is flexible food bags, crinkly garbage bags, as well as other things. Rigid pipes is your PVC. It can be made flexible with raincoats and shower curtains. Compact disc cases, heat insulation floats. See how they're different sets, okay? Now, basically, we've only talked about thermoplastic ones. So this means you can melt them down and recycle them and remold them to new shapes. A thermoset polymer is one that can't be melted down. And if it does melt down, it's different. It's not. You can't melt it down and then reuse it, basically remold it. So the reason that this is the case is because they've got these three-dimensional cross-linked things. So if you've got your high-density polyethylene, as it melts, the polymers just, like the different layers of polymers just slide over top of each other. So your thermoset polymers, they're all these like cross-linked structures. So when they melt, they can't slide away. They're too tightly locked in, which means if you do melt them, they don't melt at low temperatures, and if you really melt them, then they don't tend to survive it. You're breaking them apart. So we use them for things like handles in kitchens. That's a really good place for them because they won't melt when they're sitting on the stove. All right, that was a shorter one than the last lesson, and see you in class.